Alright, so let's take problem number 11, finding the maximum. We're gonna take the two versions using optional parameters and without using optional parameters, using only positional ones, which is basically, it's a screaming to you that I need you to use slicing. It's the same idea, right? So let's take 11 and we are trying to find the maximum. Let's take first the iterative version, right? And let's say that this is my list. Why did I, whatever. All right, so let's take the list right now, right? And we can say that we're going to start the list with the first element as an assumption, or we can start with a very small number. So any number that comes greater than it can be considered the maximum. This is basically a better approach, but let's, for the time being, let's take this approach right there. So we're going to say for I in range, and we discussed before that getting the maximum of a list is typically an O of n kind of algorithm, right? So if that element was found to be greater than maximum, then typically it's going to be the new maximum. And here you can say that the program is done and you have 100, right? So if I'm going to use the optional parameters recursively, so let's take that this is 11, finding the maximum recursively, right? And using optional params, so we would need the same thing, right? So I would say that there is a function, and this function is gonna go get max, let's call it version 1, right? And it takes a list, as you see, and it takes an optional parameter that is basically, it's gonna be this guy, right? That is going to be a very small number, right? And we would say that if L of I, right, was found to be greater than M, the same thing that we have did there, right, then M is going to be the new element, right? So whereas I, you guessed it, I is another optional parameter that is going to be initialized with 0, right? And the base case here is that if I found to be equal to len of L, then we will just return what? Then we would just return nothing, right? And let's say that we are going to return that M, all right? Or I'm sorry, let's just return M. We're not gonna return nothing. We're gonna return the maximum. I'm sorry. Okay, so let's call get maximum version 1, all right, and pass to it the list with I being incremented by 1 with the same value of M that we achieve, right? And now let's just call get maximum version 1 by passing that list. So this is going to get you 100, all right? So let's take the other version here, right? Version B, which is version 2. Oh, I didn't know this. This is something in Visual Studio Code. That's beautiful. Anyways, let's say that this is version 2. And let's take away all of the optional parameters. And before we do anything, let me just discuss this really quick with you. Right? So this is without using the optional parameters. Before we do the solution, let's just discuss this really quickly. All right? In order to approach the second way, which is basically not needing any optional parameter, I think I would do this. I would remove everything from that function, and let me just try to sketch this with you step by step. All right, let's see. It's gonna be a tough one. Okay. So now let's say that the function is called get maximum. Get maximum, right? And I have no idea about the definition of that function. I just know that in the driver code, there's going to be a call, there's going to be a list that maybe has 10, let's say 4, 8, and 100, for example, right? This is the list, and I know the maximum by looking at it, it's 100, of course, right? And we are going to call get maximum, which is a recursive function, and pass that list to it, right? So it's going to return 100. So how this would work? Let's see. This is the first call. This is the first function call. I'm just gonna say this is function call 1 or recursive call 1. I know this is not a recursive call. This is not the start of the recursive calling, but let's just stick to that notation that we have used from the beginning, right? For simplicity purposes. All right. So let's say that this get maximum takes a list, and this is all I know about it for the time being, right? And I know that there is a kind of base case here. Right? I have no idea what is the base case, but I know that there is a base case, right? And since this is returning, let me just write this in a bolder font. Since this is returning a value, then this means that obviously the base case is gonna include a return, and there's a permanent counter return in the actual body of the function somewhere, right? So let's have this fact in our mind for the time being. Okay, so I'm not really sure how should I approach this, but for the time being, let's say that I know, me and you, we know that there is a recursive call for the same function, right? But what else? Remember, this method where you do not use no optional params, right? This indicates one thing. This indicates if I have a list, let's say that this is the list. Let's say that this is the list that I have, which is basically L, 10, 4, 8, and 100, right? This indicates two things, I'm sorry, not one thing. The first thing is that I'm going to fixate my pointer on index of 0 every time, right? So fixating on, I'm going to remove this in a minute, right? On index of 0, which is like that, right? And the next thing, just as we saw in the get consonants and in the program that we used slicing and we used it in formulating a number out of a string, right? We saw this as well when we were slicing that list, right? So these are the two concepts that you need to put in your mind whenever you hear the word that there is no optional parameter. Only positional parameters are allowed. So you're going to slice the list. The list is going to start off by having the same number of elements. Then in the next recursive call, it's going to be sliced from one or the next element or the second element to the final element. The next recursive call as well is going to be sliced from one or the second element, which is in this case 800. The next recursive call the same from one the second recursive element, which is in this case 100, and so on, right? So this concept applies and this concept applies. Just have this in mind, right? So for the time being, I know that the list I'm working on is called L, that has 10, 4, 8, and 100, right? And without a doubt, I know that I am working on, I know that I'm working on this 10, which is index of 0, right? And I know that I'm going to be slicing that list starting index of 1 till the end. And please, if you don't understand this, just go back to the program where we started using slicing in the get consonants program, and in the sum digits and I believe the formulate number from string program as well, number 7 and 8, I believe. Okay, so I know that I'm going to be sending to the next recursive call the list, but starting the second element up until the last element. Okay, so let's say that this is my first recursive call. I have no idea about the m, I have no idea about the maximum, but I'm just aware that I'm going to fixate my pointer in the index of 0, and I'm going to slice the list every time I recursively call it from the second element to the last element. This is the only knowledge that I have for the time being, alright? So let's keep on going. Okay. So we have a next recursive call, and basically this is the base case. This is the base case that I'm not really sure what should I include in it for the time being. So this is gonna call another version. Recursive call 2. So this is get max. Right? And get max is gonna take the L, like not literally, but it's gonna take the list L, right? So L in this case is going to be starting from 4, index of 4, as we slided from the index of 1 previously. So this is gonna be 4, 8, and 100, right? And I know for sure that I'm fixating my pointer on index of 0, which is 4 in this case, right? And I know that there is still a base case that I'm not really aware of, but there is a base case, of course. Any recursive function has a base case, right? And I know that there is a recursive call to get max that is being sliced from the the second element up until the last element. Okay, so this is L sliced from the second element till the end. Alright, so let's see the next recursive call. So this is recursive call 3, this is get max, right? Where we send the L or the list. Right, now we have truncated the list in this recursive call, and we have sent, notice here, we have sent L starting from 4, right? So we are sending L that is equal to 4, 8, and 100. And here we are sending L starting from index of 1, which is 8 in this case, right? So we are sending 8, 100. Okay, so we have L that is equal to 8 and 100. Okay, and there is a base case as well that we are not still familiar with. Okay, let me just leave this open like that. Okay, and now there is another function call, recursive function call for get max, where you are taking or slicing the list from the element or the index 1, which is the second element, up to the end. So we are sending L from 1 till the end. Alright? Okay, and finally we have the last recursive call, and you should know by now that this is the last recursive call because you have only one element in the list. You don't have anything to slice anymore, right? So this is recursive call 4, and this is get max like this. All right, This is get max like that. Okay, and this is the L. This is the list that we have passed and we sliced a bit earlier, which is equal to 100. And I forgot to tell you that in this recursive call, we are focusing on index of 0, of course, just as we did in the previous ones. And this is basically are going to be focusing on index of 0, since this is the only one that we have anyway. Okay, index of 0. All right, and there is gonna be a base case. Okay, and finally the same thing is going to happen here, but we didn't really go to this line because we would finish everything in the base case, so I don't really need to write this, right? So let's check the base case. There's no need to go any way further, right? Since I only have one element, I just have one element left, so I can say now without a doubt, if len of L, right, became 1, so I can say that I can safely assume that I should return that element which is index of 0, right? So I can return now that element which is 100 in this case. Alright, so typically we're gonna have this popping of the stack, and while it's returning, it's gonna return L of 0, right, which is in this case equal to 100, right? So it's gonna be substituted in place. It's gonna be substituted in place of this function call. So this is gonna be having 100 instead. Now the question is, what or where should we store this 100? Now that's the actual starting point to line up every other piece in this recursive call and in this recursive call, right? So we can store this inside the variable m. Notice that I have not mentioned m at all. I just mentioned that there's going to be returns, right? There's going to be returns, and this is obviously the first return that we have seen inside the base case. This is the temporary. I'm not going to say temporary. This is the conditional. This is the conditional return, or the base case return, right? You can just call it base case, right? Return, right? This is the first return that we have seen that's going to align the pieces, right? So this 100 is going to be stored. Let me just use a different color here. This 100 is going to be stored inside m. This is the variable that I'm going to store the maximum in, and keep on comparing it with index of, you guessed it, index of 0 right there, right? So this part seems to line up. This part seems to be seemingly aligned, right? There's no missing pieces here, right? But the problem is this part right there, it should return something, right? It should return something to the previous recursive call. Now we get that the base case has returned L of 0, which is the last element after all of the slicing that has been done, to the recursive call that was pre the last one, or the prior to the last recursive call, which is the one that is pre the base case. This is the base recursive call, right? And this is the one pre the base, right? So the one pre the base has been aligned. It has the value of m returned from the base case, right? But what about the rest? What about this recursive call? And what about this? Where is the return here? I know for sure that there is a return at some place here, right? That we didn't complete yet, right? But where is it? There should be a value that is being returned into that recursive call, or else we are going to be stuck, right? We are going to be stuck at that recursive call, which is prior to the base case, prior to the ending or the stopping base case, right? So in order to align the rest of the pieces, right, of the rest of the previous recursive calls, we need to make sure that there is some kind of return in this area, right? There is some return that is happening in this area to return something to this recursive call, so that we can pop this from the stack, and then we can pop this from the stack and return a value to this recursive call, and finally pop this from the stack and return a value in place of this recursive call or this function call, right? So what should we think about is the following. Right? Now, as we said, we know that this part seems to be aligned. This has been bobbed already, and this is waiting to be bobbed as well from the stack, right? And this is wanting to return something to the previous recursive call. And for this to happen, this area right there, notice that the control flow has returned to this function. After we returned this value, which is L of 0, and this has popped from the stack, this 100 or L of 0 has been returned into this line. And this line have taken, or the interpreter, Python interpreter, have taken this 100 and assigned it into M, right? And assigned it into M, right? So when the control goes back to this BART, we're gonna start continuing executing the rest of the lines. So the rest of the lines obviously should contain some return function right there, or some return statement right there. Okay, so we can say that, let's say that we have M now, right? In this recursive call, we say that we have M, that is 100, which is being fetched from the base case, which is being assigned from the base case, right? So we can say that, notice or remember something, didn't I tell you that we are going to work on the index of 0 in every iteration? That's the most important guy right there, right? In the base case, we returned index of 0. In the prior cases, or the prior recursive calls, we are going to compare index of 0 to the returned value from the base case, which is basically M, right? So I'm going to say something. Come on, what's going on? So let's say if M is greater than L of 0, and notice that in this recursive call, L of 0 is basically, in this recursive call, L of 0 is basically 8, right? And M is 100. If M, which is 100, is greater than L of 0, which is 8 in this case, then this means that M still is the maximum. There's nothing that is topping that 100. So return, and this is the most important part, return that M. All right? So this is the actual return that is going to be returned into that code stack, right? Else, what if it wasn't that case? What if for some reason, let's just assume that this 10 was basically a, this 10 was actually a 1, right? And we assign that 1, right, into M. So M has 1, and this is 8, 1. And L of 0 in this recursive call is 8. So if 1 is 1 greater than 8, no, 8 is greater, then else is going to be executed in this case, right? So else we are going to return the greatest one, or the greater one, which is in this case return L of 0, the greatest out of M and L of naught, or L of 0, right? So let me just rewrite all of this without changing the 100. Let's go back to our previous example. So else, I would just say return L of 0. Okay, so in this case, this if statement is going to prove true. So this return, right, this statement is going to return M that has the value of 100 to that function call. So instead of that function call, we're gonna have 100 being returned and substituted here, right? And as we said that there is M right there, so this is gonna be reflected in all of the recursive calls with the same exact function. There's gonna be M, right? And this tells you something, that you do not reach the final version, especially when you're doing recursion. You do not reach the final version of the function unless you do some kind of tracing and write it on pen and paper and see what is the base case returning. Like you try to take the simplest possible list, the simplest possible sub-problem, maybe something like 3 elements or something, and try to work it out on a pen and paper and see what is the base case is going to return, right? And notice something here, that this m that is being assigned as m of L node, right? This is typically what we used to do at the start of an iterative algorithm, right? So if we were using a loop, the first thing that we used to do was basically take from that list L of 0, the first element, and put it inside M and start comparing that M, which is we initialized as L of 0, with the rest of the traversed elements along the list, right? In recursion, it's a bit taken in a backwards fashion, where that element or that variable, maximum variable that you used to initialize at the beginning of an iterative version of the get maximum function, now you are initializing or assigning that m value from the end, from the last recursive call, right? You are figuring out the value of the maximum from the last base case, from the last recursive call, like as we saw here, right? But continuing, the same exact return, the same exact block that we add here, we're just gonna add there. So if m is greater than L node, then return m. Else, then return the greatest one, like that. Now, if we took a closer look, you're gonna see that L of 0 is 4, right? And you're gonna see that m that is being returned is basically 100, right? So 100 is greater than 4, so return m. So this is gonna be, of course, this has bobbed from the stack, and this is gonna bob from the stack, returning m as 100 here. Okay, so this is gonna be substituted with 100, and the same thing would go if m is greater than L node, right? So return m. Else, return L of 0. And L of 0 here is 10, right? And the m is 100, and obviously m is going to be 10, so this is the greatest, right? And finally, this is going to be popped from the stack, and this return statement, right, which is m equals 100, is going to be substituted in place of that guy, that function call, and you're going to have 100 at the end. Okay. All right. So let's do this. Let's say that this is the base case. If we kept on slicing, notice that I'm just gonna keep on calling that same function, right, and keep on calling it with the knowledge that I'm slicing that list from the second element to the end. So if now the length of that list I found it to be equal 1, then I'm just gonna safely assume that I'm going to return the only and the first element in it, which is L of 0, to be assigned into the prior recursive call to the end, or the last recursive call into M. So this is going to be assigned into M, and afterwards the other of the recursive calls, or the previous recursive call, is going to be checked with that. The first index of these recursive calls is going to be checked with that return value that is going to be assigned into M. So if M is greater than that first index of every sliced version, then this means that M is still persisting, M is the maximum. Else, then obviously we are going to return L of 0, right? So this is going to get you 100. Now try to think of if you are getting the minimum, what should you change? It's really obvious. The hardest problem here, in my opinion, for your level, is 13, where you want to write a program to get the first and second maximum of a list, Like here, the first and second is 144. Maybe you would have a question that is asking you to return the maximum and a minimum in a list. How can you do that recursively without any optional parameters, right?